Hi, this is Mrs. Rodriguez, your Algebra 2 teacher. This video is a review for the Chapter 7 quiz that's coming up. What I recommend that you do is that you have a sheet of paper or your spiral notebook out and something to write with. And when the problem comes up on the board, please try to solve the problem yourself first, pause the video, and then go ahead and play the video once you're done. If you get the correct answer, great, move on to the next problem. If your answer is wrong, please try to figure out what your mistake was. If you can't figure out your mistake, then please either stop by my office hours or email me or call me so we can discuss the problem. Okay? You want to be able to figure out all of your mistakes before you take the quiz. Okay? All right, so these problems are from a practice quiz that can be found in the textbook. And it is on page 484 of your textbook. Like I said, this is a review for the Chapter 7 quiz. And also there may be a couple of there's a couple of extra problems that I added that I didn't see any similar problems on the practice quiz, but you will have problems like this on the actual quiz. So I wanted to make sure you saw some of those as well. Okay, all right, so let's go ahead and get started. So Chapter 7 started to talk about exponential growth, okay? And so we have this parent function of exponential growth where it's kind of like, almost looks like kind of like half a parabola. But what ends up happening is the curve ends up kind of leveling out and it stops at a certain point where it's never going to cross, okay? And then same thing on this side over here, the other end of the curve, okay? And so this shape, that line that it approaches, that's called the asymptote, okay? And that the asymptote is where the graph will never cross that line. It'll get closer and closer and closer and closer, but it will never cross it, okay? And then there's exponential decay, so that graph is going to be going down towards the right. And again, we still have the asymptote here and here on both sides, both ends of that graph, okay? All right, so first problem says to graph each function, and then it says to state the domain and the range, okay? So what we want to do is pick values where we'll kind of get a general idea of what the function is going to look like. So we're going to start off with our x and f of x equal. Okay, so I'm going to first pick -1 as one of my values. So that means I'm going to put negative, and then I still have that 2 in parentheses. And my exponent is x, so it's -1 plus 5. And that's going to equal, well, we have 2 to the power of -1, which is 1/2. And then 1/2 times negative is going to be -1/2. And -1/2 plus 5 is going to be a +4 and 1/2. So that means on my graph at -1, when x is -1, f of x is 4.5. So 1, 2, 3, 4.5 right there. Okay, and then I'm going to plug in 0. So I have my 2 in parentheses, my exponent is 0. And then anything to the power of 0 is going to be 1. And then 1 times the negative is -1. And then I still add 5, so that's going to be a +4. So when x is 0, y is going to be 1, 2, 3, 4. Okay? And then I'm going to plug in value of 1. So I have negative, and then 2 in parentheses, my exponent is 1. So 2 to the power of 1 is going to be 2. And then times the negative is -2, plus 5 is +3. So when x is +1, y is +3. Okay? And then we can also put a couple more points when x is 2, put 2 as my exponent. So then I've got 2 to the second power, which is 4. And then negative times 4 is going to be negative 4 plus 5, which is a positive 1. So when x is 2, y is, or f of x is positive 1. And then we can see when we put x3 in for x, 3 in for x, that's the exponent that's changing. So we've got 2 to the third power, 2 times 2 is 4, times 2 is 8. So then we have negative 8 plus 5, and that would be negative 3. So when x is 3, f of x is negative 3. Okay, sorry about that. My work went away, sorry. Okay, so basically, so we had our points when we had x was negative 1, it was 1, 2, 3, 4.5. And then when x was 0, f of x was 4. When x was 1, f of x was 3. When x was 2, f of x was 1. And when x was 3, f of x was negative 3. Okay. And then when x, if we added x was 4, you would get negative 11. So that'd be all the way down here. Okay. So you can see that it's going like this. Okay. All right. So then it asks for the domain. So remember, the domain is equal to all of the x values. So x, it's going to keep on going this way, and it's going to keep going this way, right? So we would say that the domain is equal to all real numbers. And then for the range is going to be all the y values, okay? So if we look here, okay, we can see it's everything that is less than this value here, which is 5, okay? So we would say that f of x, which is another way of saying the y values, f of x has to be less than 5. It cannot be equal to 5. Remember the asymptote, it just approaches that line and never crosses it. So it's just less than 5, okay? All right, sorry, all the table got deleted. Okay, so let's go on to the next problem. It says to write, and this is an additional practice problem, so this was not in the practice quiz, but it definitely will be on the quiz. And it says to write an exponential function for the graph that passes through the given points. Okay, so you have to remember that an exponential function looks like this: y equals a times b to the power of x, okay? Where b is the base of your function and a is equal to the y-intercept. Okay, so the first thing that you have to do, hold on one sec. Okay, so what we're going to do is use the x and y values from the first point to solve for a, okay? So we have our exponential function y equals a times b to the power of x. So I'm going to put in 256, that's my y value, equals a times b to the power of 0, that's my value of x. So, well, I know that anything to the power of 0 is equal to 1. Okay, so I end up with a times 1, So 256 is equal to A. So then what I'm going to do is use A and the X and Y value from the second point, and then solve for B. So again, I start with Y equals AB to the power of X. So Y in this case is 81. A, we just figured out, was 256. And then we're trying to solve for B, and then my exponent is 4. So I end up with 81 so what I'm going to do is I have this equation. I'm going to divide both sides by 256. So I have 81 over 256 is equal to B to the 4th power. Okay, so then I'm going to take the 4th root of both sides. Okay, so and I need to do that to my numerator and my denominator. So the 4th root of 81 is actually 3, because 3 times 3 times 3 times 3 is equal to 81. And then the 4th root of 256 is actually 4, because 4 times 4 times 4 times 4 is 256. So this would be 3/4. And then over here, the 4th root of B to the 4th power is equal to B. Okay? All right, so then when you write the equation, you have Y is equal to 256. We know what A is. B is 3/4. You can write it as a decimal, 7,500, to the power of X. Okay, so that is your exponential function. Okay. All right, so next set of problems starts talking about logarithms. Okay, so what is key here is this log with base B. X is equal to B to the power of Y equals X. Okay, so you're going to be going back and forth between these two. All right, so it says here to evaluate each expression. So what we want to do is actually solve this here. So this would be equal to Y. So remember, if you have log base B, X equals Y, so then the base B, the exponent is Y, is equal to X. Okay, so if my base is 5, so then that's my base, and then my exponent is equal to Y, right? Because we don't have a value for Y. And then X is also 5. Okay, and then that it's 5 to the power of 12. Okay, so now my bases are the same, so I can put the exponents equal to each other, so Y is equal to 12. Okay, so I have log base 5 to the power of 12 is equal to 12. Okay, all right, and let's look at another problem like this. Now it says evaluate each expression, and it says to write log base 9 729 equals 3 in exponential form. Okay, so remember exponential form is B to the power of Y equals X. Okay, so our base B is 9, our exponent is 3, and then it equals the X, which is 729, okay? And it wants it in exponential form, so we're just going to leave it just like this, okay? All right, next problem. It says write each equation in logarithmic form. So now it is already in exponential form. We want it in logarithmic form. So remember, B to the power of Y equals X. Okay, so this is B. So B is equal to 4, Y is equal to 6, and X is equal to 4,096. We want it in the format log B x equals y, okay? So that means we're going to plug this information into this. So we have log b is equal to 4, okay? Is equal to 4. And then we have x, which is equal to 4,096 equals y, and y is 6. So now this is in logarithmic form. Okay, so we went from exponential form to logarithmic form. In the previous, we went from logarithmic form to exponential form. Okay, all right. So then, then it talks about exponential equations in the next section. So that's when we end up with variables as exponents. And if you do that, if you can get their bases to be the same, then their exponents are equal to each other. Okay, so let's look at one of these. Oh, same thing with exponential inequalities. Okay, so let's look at one. It says 4 to the power of 3x equals 1 equals 16 to the power of x. So it have to have the same base, then the exponents would be equal to each other. So right now we have a base of 4 and a base of 16. Well, 16, we can rewrite it as a base of 4 because 4 times 4 is 16, okay? 4 to the power of 2 is equal to 16. So now we end up with, we're raising a power to a power. So you multiply the exponent. So this would be 4 times 2 to the power of 2x. And then we have over here 4 to the power of 3x minus 1. So now our bases are the same. So we can set the exponents equal to each other to solve for x. So we have 3x minus 1 is equal to 2x. So now we just solve this like we would a regular multiple step equation. So I want my variables on the same side. So this would be 1x minus 1 equals 0 on this side. I would add 1 to both sides of my equation. And so x would equal positive 1. Okay? All right. And then the property of equality for logarithmic functions. So use the following property to solve logarithmic equations that have logarithms with the same base on each side. So it's going to be very similar. If you can get the bases the same, then you're going to set what is in place of x, okay, where the x is, you're going to set those equal to each other. So here we can see we have log base 7 on both sides of our equal sign. So we're going to set the values of x equal to each other. So negative x plus 3 is equal to 6x plus 5. Okay, so I want my variables on both sides. I'm going to add 1x to both sides. So I end up with 3 equals 7x plus 5. And I've got a two-step. I'm going to subtract 5 from both sides. 3 minus 5 is negative 2. And I've got 7x over here. And then I would divide both sides by 7. So negative 2 sevenths is equal to x. Okay? All right. And we were able to do that again because the bases were the same. Okay? So now we have a logarithmic inequality. Okay? So same idea, but keep in mind for logarithmic inequalities that x has to be greater than 0. Okay, that is key. X cannot be negative. Okay, x has to be greater than 0. Okay, so let's go ahead and look at a problem here. So if we have log base 2, x is less than negative 3. Okay, so we end up with, we write this as an exponential equation, remember, which was b to the power of y equals x. So in this case, b is equal to 2, and then y is equal to negative 3, and x is equal to x here, okay? So in place of b, I'm going to put 2. My exponent is -3, and then I have x over here. Okay. So then I have x is less than, and then this 2 to the power of -3, that is a fraction. So that's 1 over 2 to the power of 3. And 2 to the power of 3 is 8. So x would be less than 1/8. Okay, so that would mean that my value of x has to be less than 1/8, but it also has to be greater than 0, because remember that x cannot be less than 0. It cannot be a negative, okay? So it always has to be greater than 0, okay? All right, so thank you for watching this review for the Chapter 7 quiz. If you have any questions, please stop by my office hours, call, email me, and I would be happy to help you. Okay, that's what I'm here for. All right, you have a great day, and hopefully see you soon.